So 3 of them we all know. What's the 4th one?
That's mine.
Right. All right. So let's start over with solids. So solids have a definite shape. Okay. So solids have a definite shape. So I have up here my block of solid gold. It's in the shape of a cube, and it's going to stay that way. That's its shape.
That's not real gold, is it?
Yes, real gold.
No, it's not.
It's
Solids also have a definite volume. This cube of solid valuable gold has a volume that I could measure. I can measure the size. I can multiply length times width times height and find the volume of this solid gold of extremely valuable. No, too good. So solids have definite shape and definite volume, and we'll see that that's a little bit different than the other states of matter. Okay, solids are difficult to penetrate. It's not easy to pass into a solid for other material. And you can see in this diagram, the molecules in solids are fairly compact. They're vibrating. They don't have a lot of freedom of movement.
They don't look like they're right.
what would Jello be?
Yeah, there's lots of like weird examples. So Jello, Play-Doh, that goo stuff we made. Though there are some things that sort of are very soft, flexible. Solids, other things like that goo we made with the borax and stuff, that's a non-Newtonian fluid, it's called. We read a little bit about that, where it's somewhat solid-like, somewhat liquid-like, depending on the forces that are being applied. You know, you can roll it into a ball and it stays in that shape, but if you put it down on the counter, it'll slowly ooze into a puddle. So it's a certain type of fluid. So there's some different examples, such as those things. All right, liquids. Tell me about the shape of a liquid. Does it have a shape?
Takes the shape of it.
Yeah, it takes the shape of its container. So here we have a liquid shaped like a woman. Mrs. Butterworth. Not Mr. Butterworth, Thomas. It's Mrs. Butterworth. What's that? Mr. Butterworth? Oh, I think it looks like Mrs. I don't know, I guess.
Oh, I thought it said butterworms.
Worms?
You know, it could look like.
Have you ever gotten Mrs. Butterworth's syrup from the grocery store? Or if you ever got like a honey bear, little honey that's in a little bear container, a honey takes the shape of the bear container. But it does have a definite volume. You can take the honey bear, pour all the honey into a graduated cylinder, and measure its volume. It does have a definite volume. Yes, Brandon? If they can get it, they would, yes.
Do they like break the size?
Like who? All right.
Yeah.
Gases, on the other hand, so in the liquid, you see the molecules that are shown here in the picture. They're not as arranged in an orderly fashion. They have more freedom of movement, but they generally stay together. Okay? And then we have gases, where the molecules sort of are all on their own, sort of just flying around. They have no definite shape and no definite volume. Their shape and their volume is whatever the container they're in. So gases will expand. Even if you have a tank of propane, okay, the propane in there is in the shape of the container. When you put helium in one of those helium balloons, the helium expands, filling up the balloon, and takes the shape of the balloon.
Wait.
Brand?
Take the shape of the helium. What does the helium?
The balloon, the outer shell of the balloon is what has a shape. The helium expands to fill it up.
Okay, so say like I got a glass of water.
I got a glass of water.
Then all you have to do is freeze it to turn it into
All right,
ice.
why did I have to say that?
No, it's a part of my thingy, like theory, you know, theory. So if I threw the glass of water in the air, is that why it doesn't go like right like the way I threw it because it's sitting on like gas molecules in the air?
No, it's because of
I guess. I don't quite understand your question, but sure, Sophie, that's exactly what happens. All right, the fourth state of matter is plasma. Now, plasma is kind of hard to explain because we don't have a whole lot of direct experience with it here on the surface of the Earth. But plasma is the most common state of matter in the universe.
Why don't we have that?
Plasma is found mainly where?
in stars.
Space and stars are made mainly of plasma. It is sometimes called a superheated ionic gas where the electrons of the atoms have been stripped off, and so you have sort of positively charged nuclei with negatively charged electrons around them. It's electromagnetic, so it responds to electricity and magnetism. Okay? Often it's found at very high temperatures. It can be found in various places on Earth. Lightning, for example, is a plasma. Okay? You can. Stars are mainly plasma.
What about plasma torches?
I'm not sure. Or somebody in the last class asked about like a plasma grenade or plasma gun from some video game.
I think Star Wars.
Yeah, could be. A plasma drive. Yeah, Matt.
Is there plasma and plasma TVs?
I believe there is. Yes, I believe there is. Where if you run electrical, if using electrical currents in gases, you can sort of strip off the electrons, and that's what makes a plasma. Sophia?
Did you say that they're like magnetic?
Yes.
So if I took a really big, really tall magnet like that could reach to the stars, could I get a star?
Sure. Yes, Thomas. All right, we gotta get moving here, people. Yes, Thomas.
What would happen if you like ingested plasma?
It'd probably be bad for you. It might be hazardous to your health. Brandon?
Like drinking 6 creamers.
That if you put like something in the microwave and you turn on the microwave, it makes plasma and then like it's just floating around.
Yeah, I have microwaves, yep. All right, so most pure substances, most simple compounds and all elements have sort of a natural state of matter, room temperature. Water, for example, is what? Liquid. Iron, solid. Oxygen is a gas abnormal.
I used to be a liquid kid.
But they all can be interchanged. So you can heat up water and turn it into a gas. You could cool down oxygen, you could turn it into a liquid. You could take iron and you could melt that iron and turn it into a liquid. So the states of matter are interchangeable by adding and subtracting and removing heat. All right, when we talk about matter, there can be physical changes to matter and chemical changes. So we talked about this a little bit in our chemistry unit. Physical changes are changes when you're not actually creating a new substance. It's still the same substance. Got some writing to do there, Robert.
I am very fascinated. Reminds me.
So a physical change, there's no new substance formed.
It's like something that like has atoms in it.
No, fire, when you see fire, what are you seeing? Fire.
Oxygen.
No,
Yeah.
energy. You see the light energy when you see the flames, heat energy when you feel the heat coming off of
And then when you see
that.
the
But the
wood.
wood, for example, if you're burning a piece of wood, the molecules of the wood are being transformed into water, carbon dioxide, carbon monoxide.
And then-
So that is matter. But when you say you see a fire, you're seeing the flames, that's energy.
And then the little bird.
Yes. Thomas?
In a light bulb, it has a little wire thing.
Filament it's called, yep.
Okay, so the wire thing, why is it like hot and
Because when you heat up this, they're made of whatever tungsten or other types of metal, that when it's heated, it glows. Okay, you know, when you heat up metal really hot, yeah, it turns red. If you have like something, one of those fireplace pokers, and you put it in the fire long enough, it turns a reddish color. Well, those are made of very thin materials, very high resistance, that can glow very brightly when electricity is passed
Like a
through.
brand.
What's that? No, it won't glow. Just
Like a brand.
yes. All right. So, for example, some physical changes might. You take ice, you melt it to liquid water. Well, that's just a physical change. Okay. That's a physical change. It's still water. Okay, if I have dry ice, okay, it can change from a solid. If you ever have dry ice, something getting packed in it, goes from a solid directly to a gas. It's all carbon dioxide, so it's not changed any new form. That's a physical change.
Doesn't it change the, if you like, can you have liquid dry?
No, it goes from, it sublimates, that's called. Salt water, if I take some water and I add salt to it, the salt dissolving, that is a physical change. It's not creating any new substances, it's still salt molecules and water molecules.
So the carbon dioxide just decides it doesn't like that.
It doesn't decide, it's just, yeah, solid carbon dioxide will sublimate. How about if I take Jimmy's notes and I rip them up? Is that a physical change or a chemical change? Is there any new substance here?
No.
No, this is still paper, okay? And it's not a new substance, and I can't really undo it. But that's a physical change. So ice melting, carbon dioxide sublimating, dissolving salt in water. All right, chemical changes are also another type of change that can happen in matter. And that, a chemical change is when you actually have new substances created. Now,
It's like if you take rock and put it in like the kiln,
yeah.
it makes it into rock.
Well, it doesn't make it a rock, but I think there are chemical changes that happen to the clay when it's heated like that. So, if you take a piece of paper and burn it, the actual material of the paper is changed from one form to carbon dioxide, water, carbon monoxide, so it's changed into something else. If I take iron, a raw iron, if it's exposed to moisture and oxygen, it will oxidize, it will rust, and that's an example of a chemical change.
How does burning paper consume, that and takes too long?
How does it?
Yeah,
It just
like
does. That's one of the, there's moisture is released when something's burned. Yeah.
It's kind of hard to write through.
So, you know a chemical reaction is taking place if, there's the rusty ends. Heat is released from, when you mix, if you mix two things together, heat is released, often that's a sign of a chemical change. If the bubbles are formed, if it becomes cloudy and a precipitate forms, those are signs of a chemical change.
Last year? Okay, I didn't know, it sounded like a sneeze, but it also sounded like a cough.
those are signs of a chemical change. Two more things I think today. So in a chemical change, there's no loss of mass. There's no gain in mass. It's still the same amount of stuff, but there may be a change in value. Yeah, this goes on the next. You guys were done with that slide?
No.
Wait, what's the cause thing? Is what?
I'll go back.
Precipitation.
Precipitate. Not precipitation.
What? I wasn't knowing that one either.
No.
I know, you're so sad science is over. It's okay. You'll be back tomorrow, don't worry.
No, we're not.
Why?
No,
Yeah.
no, we're not. I'm sad.
You are sad.
Maybe it's not. It's sad. Yeah.